this workshop is on solubility and net ionic equations. And so what we're going to go through today is number one, the rules of solubility of compounds and to find out whether something is soluble or not. Number two is net ionic equations. Then we're going to have some practice problems for solubility and net ionic equations. And then fourth, two challenge problems that are a little bit more difficult. So number one, solubility. What is solubility? So solubility is the ability of a solid, like a salt, to dissolve in the solvent, which is usually going to be water in chemistry right now for you guys. In chemistry, a compound is soluble if it dissolves in water and insoluble if it does not. This is different. This is when the ions separate and the intermolecular forces interact with the molecules in the solution. So it's not the same thing as melting. Melting is, a phase change where a molecule changes from a solid to a liquid state. This is just that the ions separate and are surrounded by solvent molecules. So when a compound is soluble in water, it forms strong electrolytes, which are substances that conduct electric current as a result of dissociation into positively and negatively charged particles called ions. So you guys all should have gotten this solubility table in your lab packets, and it gives some of the guidelines and rules to try to decide if an ionic compound is soluble or not. So you're going to start off looking at to see whether it fits one of the rules for compounds that are soluble, and then look to see if it fits into one of the exceptions. And then second, you're going to, if you can't find your ionic compound there, you're going to look at the insoluble compounds and see if it's one that's always insoluble besides the few exceptions that apply there. So compounds that are usually always soluble are salts that are made of ammonium and salts that are from the periodic table 1A. So that's with lithium, sodium, potassium, rubidium, that first row. And there are no exceptions to that. Any ionic compound that you have that has ammonium or 1A, they're all going to be soluble. The second are salts that are made from the halogens, chlorine, bromine, and iodine. And those are most of the time soluble, except if they are paired with Ag, Pb, or Hg. And then you've got salts, nitrates, acetates, chlorates, hyperchlorate. And those are all going to be soluble with no exceptions. And then you have the salts of sulfate, and those are all going to be soluble unless they're paired with barium or lead. Those ones will be insoluble. And next category is ones that are always insoluble. And those are carbonate, phosphate, and oxygen. They are always insoluble unless they are paired with ammonium or the periodic group 1A metals. And then salts of sulfur and hydroxide are always insoluble unless they're paired with ammonium, all group 1A, and any of the group 2A, starting with calcium and going down. So calcium, strontium, barium, and radium. So here we have some examples that I'm going to walk through on so we can see how to use this chart. So I've got the chart at the in the corner, and the first example we're going to look at is just salt, NaCl. So I'm going to start looking for Na or Cl in either in the soluble compound, and I can see that chlorine, salts of chlorine, are always soluble, and the exceptions are if it's with silver, lead, or mercury, and that doesn't pertain here. So NaCl will be soluble. Hg2Br2, so that's into that same category where salts of bromine are soluble, except for Hg2. So that would be an insoluble. So you can see, I went here, saw the bromine, and then Hg2 is insoluble. And ammonium chloride, if we look at soluble compounds, all salts of ammonium are soluble with no exceptions. And then chlorines are also soluble. So that will be a soluble compound. HClO3, look at soluble. ClO3 is right here, and that's soluble with no exceptions. So that acid would be soluble. Sodium acetate, it's also in that same category. We have the acetate ion, and it's soluble with no exceptions. And Na is also a periodic group 1A metal, so it's also soluble. Calcium phosphate, number 6, I'm looking through my list of soluble compounds, and phosphate falls under the insoluble compounds. So then I look to the exceptions to see if this falls into an exception. And it says that for phosphates, if they're with ammonium or periodic group 1A, then they are soluble. Calcium is in periodic group 2A, so this would be an insoluble compound. And then the last one, ammonium hydroxide, ammonium are all soluble. But then we have in the insoluble compound that OH are all insoluble. But when I look at the exceptions, it does list ammonium as an exception. So right here, so it would be a soluble compound. Now we're going to go over net ionic equations. So how species are written in ionic form. So here's a summary of how you're going to write the species. If they're salts, ionic compounds, if they're soluble, then you're going to write them separate as their own individual ions. So like Na plus, Cl negative. If they're insoluble, then you're going to write them as the intact solid. If we're doing acids, if they're strong acids, then we're going to write them as their ions. And there's a list of the 6 strong acids. And if it's not one of those 6, meaning it's a weak acid, then you're going to write it as an aqueous molecule, so not separated into its ions. Bases, the soluble metal hydroxides, which are strong bases, those you're going to write as ions. The insoluble metal hydroxides, you're going to write as intact solids. And ammonium hydroxide, which is a weak base, you're going to write as an aqueous molecule. So here's the steps for how we're going to do this. So if we have, so the first step is to write the molecular equation. So write the chemical equation like you normally would. So for our example that we're going to work through for all these steps, we're going to write the chemical reaction, the chemical molecular equation for the reaction when we mix sodium chloride with silver nitrate. So we've got, let me turn, this is going to act weird unless I turn off the pointer. Why didn't the pointer off? Okay, so sodium chloride is NaCl, plus we're going to add silver nitrate, AgNO3, and this is just a double, double switch where the Na now is going to partner with the NO3 and the Ag with the Cl. double replacement. That's the word I was thinking of. All of these are, sodium is a positive one, chlorine's a negative, positive, negative. So we don't have to do any balancing here because they're all just 1-to-1 ratios. Let's move to the next page. So step 2 is writing the ionic equation. So the rules to doing this is are the soluble compounds in an aqueous state are written in terms of their ions. The insoluble compounds are written in terms of their molecular compound. Weak acids are written in terms of their molecular compound. And compounds that are solid, liquid, gas are written in terms of their molecular compound. So these are those rules that we stated earlier. So if we go back and do the one that, so the reaction we just did, the molecular equation was NaCl plus AgNO3, giving us NaNO3 plus AgCl. So now to write the total ionic equation, we follow these rules. So sodium chloride is soluble, so that we need to write these as their ions. So we've got sodium cation plus chlorine, and then AgNO3 is also soluble, so we'll write that as ions. NaNO3, according to our rules of solubility, is Na is a period 1A, so it is a soluble compound, so we'll write that as ions. NO3 negative. And then AgCl is not soluble according to our rules. So that we are going to write, since it's not soluble, that means it precipitates out and is going to be a solid. So that's how we would write our total ionic equation. Now, step 3 is that some of the ions appear on both sides of the equation. These are called spectator ions because they do not participate in the reaction and they are canceled. So in our last example, I'm not going to write the aqueous, but all these should have aqueous after them. But just quickly, we have, these were the ions that we had. And when we wrote the products, there were 2 ions also, and only one of the ionic compounds was a solid. So NO3 negative and Na are on both sides. So that means they are spectator ions. They're not participating in the reaction. They're there and they're facilitating the reaction, but they're not directly a part of it. So we can cancel and cross these out when we write the net ionic reaction. And that's step 4. The next slide will show up, but since I have this drawn here, I'm going to write it out. So the net ionic equation is just writing it without the spectator ions. So that we would have chlorine plus silver gives us silver chloride solid. So that would be our net ionic equation. Okay. So step 4, what we just did was to rewrite the chemical equation after spectator ions are canceled. So now we've got section 3, we have some practice problems. So let's do, so problem number 1, we're going to determine whether the following compounds are soluble or insoluble in water. So everyone, hope maybe you've got that chart in front of you, or if you could write down like the first one, we could go back and look at the chart. So the first one we have is barium sulfate. So if we go back to our chart,
It is insoluble.
barium sulfate, let's see. Yes, you are right. So it's insoluble because if we look, oh, this is not the right chart.
It's an exception. Barium is an exception.
Yeah, you're correct. The salts of sulfate are soluble except for barium. So it would be insoluble. Let's go back to the next ones. What about silver chloride?
Silver chloride. Silver chloride. Silver chloride. It is insoluble.
Yeah, correct. What is the exception that makes it insoluble?
The silver.
Yeah. So chlorines are generally soluble, but silver is an exception to the rule. So that would make silver chloride insoluble. How about the next one, potassium nitrate?
Should always be like soluble.
Yeah. So let's write, all right, insoluble, insoluble. And then potassium nitrate is soluble. What about sodium carbonate?
It is soluble.
Yeah.
Yeah.
Because sodium is group 1. It is always soluble, and carbonate is soluble. So when they pair, that's soluble. It is soluble.
Yep. So, and also to the side, I'm going to write, so if this was insoluble, that means you leave it written like that with a solver, with a S for solid. Silver chloride is also insoluble. So that means when you're writing your reactions, you would write it like this. Potassium nitrate, soluble. So it would be written like this. Sodium carbonate, soluble. So we'd write the ions out. How about copper 2 hydroxide?
It is insoluble.
Correct. Yeah, which one?
Hydroxide is insoluble.
Yep, and it doesn't fit an exception. So we'll have copper 2 plus aqueous. Oh, what am I doing? I knew as I was doing it that I was doing that wrong. So we're going to write that as a solid. How about copper 2 ammonium?
It's soluble.
Yeah, it's soluble because ammonium is always soluble. So this one will be in its ions. What about barium hydroxide?
Insoluble. Insoluble, I think.
It's actually is barium is one of the exceptions to the rules that hydroxide's not soluble. So this one will be in its ion form. Oh, geez, my pen's acting weird.
Really?
Yeah. There'll be 2 OHs here.
Oh, yeah. It
You
is
see
soluble.
on the list that says, yeah, that barium is one of the, oh, there'll be 2 ammoniums here too. And then what about lead 2 chloride?
I think it would be insoluble since like lead is not soluble with Cl.
It is
Yeah,
insoluble.
it's insoluble. And so we'd write it as PbCl2 solid. So does anyone have questions on how to use the chart or how to figure out if these ionic compounds are soluble or not? Okay, we will move on to doing the equations then. Okay, so problem 2. Write the balanced, complete net ionic equation for the following reaction showing the following: the balanced molecular equation, the total ionic equation, and the net ionic equation indicate the state of the neutral species. So, you know, what indicate like the phase that it's in. Is it aqueous, solid, liquid, gas? So I'm going to give you guys like 4 minutes to work on this, and then we'll get back together and solve it. Okay, I think we'll start looking at this. So for the molecular equation, here we're just writing out like the regular chemical balanced equation. So magnesium sulfide plus copper 2 chloride Come on, pen, don't act weird. There we go. And then these are double replacement reactions. So we're just gonna have them switch partners. And remember, magnesium is a +2, sulfur is a -2. Copper, because it's copper 2, is gonna be a +2, chlorine's a -1. So we'll have magnesium chloride plus copper sulfide. Now we need to balance the equation. We have 1 magnesium, 1 sulfur, 1 copper, 2 chloride. So we're all balanced. Now to write the total ionic equation, we need to figure out whether these ionic compounds are soluble or not. And we can add the little phases here. So what about magnesium sulfide? Is that soluble or insoluble? So if we look at our chart, sulfides are all insoluble unless it's the row 1, ammonia, or it's periodic 2A, calcium down. Magnesium is right above calcium, so it doesn't fit into that exception. So this is going to be a solid. So for our total ionic equation, we'll write that as a solid. What about copper chloride?
It is soluble.
Soluble.
So yeah, we can separate it.
Yeah, perfect. So we'll write
Cu2 plus and 2Cl minus plus 2Cl minus.
perfect. Yep. Remember, you gotta put the subscripts become go out front because we have to make sure we have 2 of them. And now what about magnesium chloride?
Yeah, it's soluble.
It is soluble. Yep. So magnesium 2 plus.
And 2Cl minus plus 2Cl minus.
And we'll write aqueous here. And then what about copper sulfide?
Soluble. No, it is not soluble. It's solid.
It's solid, yep, because sulfides are insoluble and copper is not an exception. So we'll write that as a solid. Now for our next step, we need to find where the spectator ions are. So what are spectator ions here?
Cl minus Cl.
Yeah, Cl is an ion on both sides of the equation. So that means they're spectator ions. So we will not include them in our net ionic equation. So our net ionic, but that's it. Like copper is only an ion in the reactant side. Magnesium is only on the product side. So we only have one spectator ion here. So our net ionic will be magnesium sulfide solid plus copper 2 plus aqueous gives us magnesium 2 plus aqueous plus copper sulfide. That makes sense to everyone?
Yeah.
Oh, good. So we're going to go to our next practice problem. So now, why don't you guys take a couple minutes? We'll give you like 3 minutes to do this one. Strontium bromide aqueous plus potassium sulfate. And see if you can write the molecular equation, the total ionic equation, and the net ionic equation. So strontium bromide is SrBr2, and that tells us it's aqueous, plus potassium, K2SO4, aqueous. We do our double replacement, so they just switch. And strontium is a 2 plus. Bromide is a -1 charge. Potassium's a +1, and sulfate's a -2. So we have SrSO4 plus KBr. Oops, wrong. Yeah, KBr.
Yes, KPR.
And then this one, we need to balance it. We have 2 potassium and 2 bromide.
So we need 2. Yeah.
Yeah, perfect.
And bromide. Yes.
So they've told us strontium bromide's aqueous and potassium sulfate's aqueous. And since they're soluble, what about strontium sulfate? Is that aqueous? Is it gonna, I mean, is that soluble or insoluble?
I think it is soluble.
Sulfate is, salts of sulfate are soluble unless they're with barium or lead. So yeah, it's going to be soluble also. And then while I'm here, let's look up potassium bromide.
It's soluble.
Yeah, it's soluble, right? Because bromine is soluble and potassium is not one of the exceptions.
Potassium is group 1A.
Yes, yeah. So, well, this is going to be an interesting one. I think they wrote, this one might be wrong. So total ionic, they're all going to be ions.
Yeah.
So Sr2 plus.
2 plus 2Br minus plus 2K plus SO4 2 minus. Yeah, equal SR2 plus SO4 plus SO4 minus 2 minus. Yeah, and 2K plus and 2Br minus. So we cancel all of them out.
Yes. Yep.
So there will be no reaction.
Yeah, so there's no reaction. They're all right? They're all spectator ions. They're all just going to be separated into their ions in the water, and there's no reaction. The way that the answer they had here was they had this as soluble. So if that was soluble, insoluble, a solid, then the net ionic equation would have been, the strontium wouldn't have been a spectator ion, right? So this is what they had, but it's wrong because this is aqueous. It's not a solid. So that's a good example of one. And your professors can do that. They can, give you one where they're all ions. So now let's try number 3. Barium hydroxide with sodium sulfate. So I'll just give you guys like 2 minutes to try to figure this one out on your own. So if we have barium hydroxide, barium is a +2 charge, hydroxide is a negative, plus sodium sulfate. Sulfate's -2, sodium's a +1, and do the double replacement. So we got barium sulfate plus sodium hydroxide. And if we balance these equations, we need 2 OH and N and sodium, so we just have to put a 2 there, and then we're good. Now let's look at the solubility of these ionic compounds. Is barium hydroxide soluble?
No,
It's not. What's the rule here?
because hydroxide is insoluble and barium also insoluble.
So you're right, hydroxide is insoluble. What are the exceptions to the hydroxide rule? So hydroxides are insoluble except if they're with ammonium.
This is soluble. Sorry.
Yeah, it's going to be soluble, because it's barium is a period 2A and it's below calcium. So it will be soluble. How about sodium sulfate?
Should be.
Sodium sulfate is soluble.
Yeah, so we're gonna write that as ions. Oops, for aqueous here. Put aqueous here now. What about barium sulfate?
It's insoluble.
Yep, this one's not a part of an exception. So that's going to be a solid. And then what about sodium hydroxide?
Sodium hydroxide is
Be insoluble.
insoluble.
So
No.
that hydroxide's usually insoluble, but this is going to be one of those exceptions because sodium is a period 1A molecule.
Yeah. Oh yeah.
So now we've written a total ionic equation. Now let's see if there are any spectator ions. So we have OH on this side and this side. So OH is a spectator ion. Sodium's a spectator ion. And the rest, the barium and the sulfate, are in the reaction. So now we can write our net ionic reaction. Barium 2+ aqueous plus SO4 negative gives us barium sulfate. Okay, now we've got a little bit more difficult challenge question. challenge problems. So see if you can do this one. Cobalt-3 bromide plus potassium sulfide. And I'll give you guys 2 minutes to work on this. Okay, let's start going over this one. So we've got, starting off, cobalt-3 bromide. So we've got
Cobalt COBr3.
yeah, perfect. And then how about potassium sulfide?
K2SRRS.
Yeah.
Yeah, equal CO2S3.
And then our last
KBr.
KBr. Yeah. So this one was a little trickier because cobalt is positive 3, bromine's a -1, potassium's a +1, and sulfur's a -2. So how about cobalt-3 bromide? Is that soluble or insoluble?
It is soluble.
Yeah. How about potassium sulfide?
Soluble too.
Yeah, it's always so.
How about cobalt sulfide?
Insoluble.
Correct. And then potassium bromide.
Soluble.
Perfect. So now let's write out all our species. Oh, oops, sorry. I forgot a step. We need to balance the equation. And if no, a couple of you guys have seen me as a tutor, and I'm always saying
We
that.
need two. We need two before. Yes, 2. And
Two
we need
there,
3. Yes.
3
And
there,
yeah, stay the same. And the last one is 6.
6. Yep. I can't believe I missed that because that's always, even if your professor gives you the equation, always check and make sure it's balanced because they like to trick you. So now we're balanced. Now we can write our ions. So we've got 2 cobalt. Oh, that was not a C. And then we got 3 brom.
No, 6. 6. 6
6.
BR.
Oh, good job. Good catch. It is 6. Forgot the aqueous here too.
And 6K. 6K plus.
1 second. My pen's acting up again. Come on, pen. Okay, let's plus 6K plus.
Plus 3S minus 2 minus, yes.
And then this is a solid.
Yeah. And 6K plus 6BR minus.
Perfect.
So we cancel 6BR
Yeah.
and 6K.
My pen's wanting to do its own thing right now. So now let's look for our spectator ions. And here they wanted us to write them down here. Let's see if I can do it without, since this is acting weird. So our spectators are, we've got potassium and bromine. So we can write bromine and the potassium are spectators. And if we write our net ionic equation, we've got 2 cobalt plus 3 sulfide. You guys get the point, even though my pen's not drawing. And that is solid. And these are aqueous. Okay, we've got one more to do. Okay, give it just like 1 minute since we're running out of time. Sodium carbonate and barium hydroxide. Maybe just look up their solubilities really quick in the next like minute, and then we'll do it together. Okay, let's just go over this last one quick. We've got sodium carbonate. So that's, oops, let's draw. Oh, come on, go back. There we go. Okay, sodium carbonate plus barium hydroxide. And let's do the little switch partners. So now we got sodium hydroxide and barium carbonate. We balance these. We can add a 2 here. And then is sodium carbonate, is that soluble or insoluble?
Soluble.
Perfect. So those are going to be aqueous. What about barium hydroxide?
Soluble too.
Perfect. And sodium hydroxide?
Soluble.
Yep. And barium carbonate?
Solid.
Yep, it's a solid. It's insoluble. And did we balance? Yes, it's balanced. So now we can write the total.
2Na, 2Na, 2 plus, 2Na 1 plus, CO3 2 minus, and then Ba 2 plus, 2OH minus, 2OH.
Thank you. 2 there.
Yeah, and then 2OH minus, and then barium.
And then if we cross out our spectators, we've got OH, OH, Na, Na. So our spectators are the sodium and the hydroxy. And we can write our net ionic equation. CO3 2 minus plus barium 2 plus. Barium. Cobalt. So that is our net ionic equation. So does anyone have any questions? Thank you so much for joining me tonight.